Think about everything Earth gives you. Water, air, gold, silver, copper, iron, coal, diamonds, oil, gas, minerals, salt, soil, gemstones. The planet beneath your feet is not just the ground you walk on. It is the single greatest supplier of everything civilization has ever been built upon. But here is a question most people never think to ask. Where exactly inside the Earth do all of these things actually come from? How do they form? And does something exist so deep down that no human being has ever laid eyes on it? Right under your feet is a world that even modern science has not fully figured out, a place that remains one of the biggest unsolved puzzles in all of geology. Today, we are going to go down there. Layer by layer, depth by depth, we will uncover what the Earth is hiding beneath its surface. Along the way, we will also tackle a question that sounds almost too simple. If the ground has water underneath it, why does it not just cave in? Everything you are about to hear is backed by scientific research. If something is unclear, leave a comment and I will clear it up. From orbit, Earth looks like a blue and white marble floating in black space. Move in closer and the picture becomes more defined. You can clearly make out two things, land and ocean. If you treat the entire surface of Earth as 100%, then roughly 71% of it is water. That is the ocean, covering nearly 3/4 of the planet. The remaining 29% is land. Now break that 29% down further. Only about 3% of Earth's total surface is where people actually live. Cities, towns, villages, everything. Around 11% is farmland, used to grow the food that feeds the world. Everything else, the mountains, deserts, rivers, forests, roads, and infrastructure, fills up the rest. Here is the number that really puts things in perspective. When measured against the entire surface of the planet, human settlements cover just 0.5% of Earth. 0.5%. And yet, from that 0.5%, we have managed to pollute the air, contaminate the water, strip the forests, and destabilize the climate. We occupy less space than almost any other species, and cause more damage than all of them put together. In a very literal sense, we function the way a disease does. Small in scale, enormous in impact. I want you to hold on to that picture of the full planet, because the resources that fuel our world, oil, gas, and more, are not just buried under land. A huge portion of them lies beneath the ocean floor. You know Earth is round. You know it is solid. But solid does not mean uniform. Earth's interior is built in 4 distinct layers, each with its own composition, temperature, and behavior. On the crust 2. The mantle 3, the outer core 4. The inner core. The crust is where everything we know about life happens. It runs from the surface down to depths of 5 to 70 kilometers depending on whether you are looking at ocean floor or continental land. The oceans rest on top of the crust. On average, the ocean is 3 to 4 kilometers deep. But at the planet's deepest known point, the Mariana Trench, the water column stretches all the way down to 11 kilometers. Below the ocean floor, the crust continues, rock on top of rock, all the way down to the next layer. One quick distinction worth making: the water in the ocean is salty. The water found underground beneath the land is fresh. These are completely separate systems, and we will get into why in a moment. Just below the topsoil, the ground is alive. Ant colonies tunnel through it, earthworms churn it, and burrowing animals make their homes in it. The shallow soil is one of the most biologically active environments on the planet. The soil changes, you start hitting sand and compacted earth. At this depth, you will also run into the human fingerprint underground, building foundations, tree root systems, water mains, and sewer pipes. What exactly you find depends heavily on where you are digging. This is typically where fresh water first shows up, the groundwater that supplies our wells and taps. It sits trapped in porous, sandy layers, waiting to be drawn up. In some places, you hit water at just 10 to 12 meters, depending on local geology. Here, buried in layers of compressed sediment, are fossils, the preserved remains of plants and animals that died millions of years ago, sealed in time. Before we go deeper, one important point: groundwater depth is not consistent. In some parts of the world, water sits just 10 meters underground. In others, you could drill for kilometers and not find it. Broadly speaking, groundwater exists from depths of a few meters all the way down to 2 kilometers, and in certain geological formations, it has been found as deep as 5 kilometers. But depth changes everything when it comes to drinking. Water shallower than 750 meters is generally considered safe. Beyond 900 meters, according to WHO and UNESCO, the water picks up so many dissolved minerals that it turns brackish, too salty and mineral heavy for human consumption. Below 2 to 5 kilometers, you will not find liquid water at all. So if water exists underground, why does the ground not collapse under our feet? Because underground water is nothing like a hidden lake or ocean sitting below the surface. It does not pool in open cavities. It occupies microscopic pores and fractures within rock, sand, and gravel. That water is under pressure, and that pressure actually pushes upward against the layers above it, helping to hold the ground in place. The problem starts when you remove too much of it too fast. When groundwater is pumped out in large volumes, the pressure disappears. With nothing to hold the gaps open, the surrounding soil and rock compact and compress, and the ground above sinks. This is not theoretical. Mexico City has literally sunk by 30 to 40 centimeters in several districts, with excessive groundwater extraction being the primary cause. 500 meters, layers of black soil, loam and sandy earth. In some regions, these same soil types appear right at the surface, pushed up over millions of years by tectonic shifts, earthquakes, and volcanic activity. 800 meters, the rock composition shifts. This is where you find limestone and gypsum deposits. Even here, 1 full kilometer underground, life persists. Microscopic bacteria survive in the rock, feeding off minerals and chemical reactions rather than sunlight. It is one of the most extreme environments where life has ever been found. 1 to 5 kilometers. 3 major rock types dominate this depth range. Shale, a sedimentary rock used in the production of cement and ceramic tiles. Sandstone, a durable building material used in construction and sculpture. Limestone, the foundational ingredient in cement, concrete, and quicklime, a chemical used in construction and water treatment. Oil and natural gas also originate in this range. The organisms that became these fuels, marine creatures that lived and died hundreds of millions of years ago, were buried under sediment, compressed, and slowly converted into hydrocarbons over geological time. These deposits tend to be more abundant under the ocean, which aligns perfectly with the fact that the ocean floor sits at an average depth of 3 to 4 kilometers. Coal forms under similar conditions and is more commonly found beneath plateau regions where the water table sits low enough to make mining practical. 5 to 10 kilometers, the rock type changes again, this time to igneous rock, formed directly from cooled magma. Basalt is used extensively in road construction. Granite, one of the hardest natural materials, goes into heavy-duty buildings and countertops. Dolerite is crushed and packed beneath railway tracks to stabilize them. 10 to 20 kilometers, temperatures here climb to around 300 degrees. This is the depth range where many of the minerals that drive global industry, gold, copper, iron, and zinc, are actually formed. Some areas also hold deposits of mica and graphite. The challenge is that humans cannot drill this deep to extract them directly. Instead, geological forces do the heavy lifting: volcanic eruptions, earthquakes, and the slow grind of tectonic plates gradually bring these minerals within reach, typically to the 3 to 4 kilometer range where conventional mining can operate. Nevada's gold mines are one of the clearest examples. They produce approximately 100 tons of gold every single year, more than any other mining region on Earth. 20 to 35 kilometers. At temperatures between 500 and 700 degrees Celsius, the pressure and heat are enough to create gemstones. Kyanite, used in jewelry and industrial ceramics, forms in this zone. 35 to 50 kilometers. Temperatures push into the 600 to 1000 degree Celsius range. The rock here is dense, rich in iron and magnesium, and extremely compressed. The 50-kilometer mark is where the crust officially ends and the mantle begins, a boundary geologists call the Mohorovičić discontinuity, commonly shortened to the Moho. At 70 kilometers we enter the mantle. This is the thickest layer in Earth's interior, extending 2,900 kilometers downward. Temperatures at the top of the mantle start at roughly 1000 degrees Celsius. 100 kilometers, this is the base of the tectonic plates, the massive slow-moving slabs of rock that make up Earth's outer shell. Their movement, imperceptible in human time but dramatic over millions of years, shapes every continent, mountain range, and ocean basin on the planet. 450 kilometers, temperatures reach 1600 degrees. Some researchers believe this depth conceals something remarkable, a hidden reservoir of water, not liquid, but chemically bonded inside a mineral called ringwoodite. Studies suggest the total amount of water locked in this zone could be greater than the combined volume of all of Earth's oceans. 1000 kilo. The material down here defies easy description. It is not solid in the way rock is solid, and it is not liquid in the way water is liquid. The closest comparison is extremely thick, slow-moving plastic. Over millions of years, its gradual flow is what drives tectonic movement, triggers earthquakes, and feeds volcanic systems. Temperatures range from 1800 to 2200 degrees. 2000 kilometers. The temperature climbs to between 3000 and 3500 degrees. The same slow, plastic-like flow continues, material in constant motion, just too slow for any human to perceive. At roughly 4000 kilometers, we reach the outer core. The outer core spans about 2200 kilos of depth and is completely molten. The dominant materials are liquid iron and nickel, churning continuously at temperatures between 4000 and 5000 degrees Celsius. That constant churning of electrically conductive metal generates something critical: Earth's magnetic field. The magnetic field surrounds the planet like an invisible force field, intercepting the sun's stream of charged particles, the solar wind, and deflecting them away before they can reach the surface. Without this shield, Earth's atmosphere would be stripped away over time, and life as we know it could not exist. The inner core, the bottom of everything. Beyond the outer core lies the deepest layer, the inner core. And here is the twist. Despite temperatures of 5,000 to 6,000 degrees Celsius, temperatures that match the surface of the sun, the inner core is solid. The pressure at this depth is so immense, millions of times greater than atmospheric pressure at sea level, that it forces the iron atoms into a rigid crystalline structure, preventing them from becoming liquid regardless of the heat. The inner core is approximately 1,220 km thick. Earth's layers at a glance. Layer, thickness crust, Chino 70 km mantle, Pino 2,900 km outer core, 2,200 km inner core, 1,220 km total radius, Tuska 390 km Earth's total diameter, measured straight through the center from one side to the other, is approximately 12,780 kilometers. If you drilled a tunnel all the way through the planet, that is how far you would travel. The radius figure of 6,790 kilometers refers to the halfway point, after which you are no longer going deeper into Earth, but coming back out the other side. That was an imaginary trip, but everything you just learned is real science. If you found this useful, hit like and share it with someone who would find it just as interesting.